Chaliye, let's get started with the word search problem. So what is a word search problem? It says that you are given a 2D array, right, of character. It can contain characters of any type, correct? Basically ASCII characters. So something like that. I'm going to copy the image and just paste it here so that I can escape from typing. Okay. Now somebody says that you are given this grid as an input, right? And you're also given a string str. Let's say str, and say the word you have to search for is, let's say, ABCB, and let's say ABC CCS. Okay, CCS. Now you are allowed to move in either of the 4 directions. You can move in either of the 4 directions. You can start from any cell you want, right? You can start from any cell you want. You can move in the 4 directions. But you have to make sure that this word is found. You have to ask, you have to check whether we can find this particular string, find this particular word in this grid. Okay. So this is the problem which is given to me. Let's do one thing. Let's find this first character. So this is the first character, assuming I'm finding ABCB, both of these, let's say, and this is the first character, right? So this is the starting point from where we can start. Now move to the cell if it is found or not. Now I can go to this cell, this cell, this cell, and this cell, right? How will I decide which direction should I move to? How will I decide which direction should I move to? So the next character which I have to look for is B, right? The next character which I have to look for is B. So I'm trying to find whether there is a B adjacent to this A, right? Whether there is a B here or here or here or here. So these 2 positions are not, these 2 positions are out of grid, so I'll not go there, right? And this position, this grid says S, and I do not want S, I want a B. So I'll not move to the downward cell. This particular cell, is it giving me a B? Oh yes, it is. So I'll go back to this B. Now I can go back. Now I have another such iteration like that. The next character which I have to look for is C, right? So I can go here, 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 and here, right? Out of these 4 cells, this cell is out of grid, so no, I'm not gonna go there. This particular cell does not give me C, so not gonna go there as well. Not F as well. This cell, hey, I have C, so let's just go there, right? So now I am at position C. Let's look for B. Can I find B? So my algorithm says you go here, 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 right? Right. So I'm not going to go there. E is not something I'm looking for, so I'm not going to go here as well. C is not something I'm looking for. But should I go back? Answer is no, right? Answer is no. We cannot go back because we've already traversed this character. So we cannot consider that one more time, right? We cannot consider that again. So we need one more grid of the same size where I can mention, right? Where I can mention from where I have come from. So I'll mark these indexes as true. So now that I'm here, I'm not supposed to go here. What I'll do is I'll go back, and do a backtrack. That way I'll keep on doing till I find A, B, C, B, right? If I do not find it through this A, I'll jump on to the next A, and I'll do the same thing for this one as well. Let me just quickly say that again. First step, find the first character in the matrix. The first character is A. So we have 2 A's, this particular one and this particular one. Start with the A, let's say start with the first cell, and then try to figure out whether you are able to go to the next cell, where the next character is there or not. So this is what we're going to do. Okay, this is what we're going to do, guys. Okay, so let me explain it to you using simple code. It should not take a lot of time. So let's write a simple function, bool exists, right? And in the bool exist, somebody has given me a vector of what? Of character, correct? It must be passed by reference, let's say, and you also have a string which you have to find. Let's call it target or whatever you want. Let's call it word. Much more simple. Okay. So this is the board where you have to do the searching, and you also have the word. Okay. What if my word is empty? What if my word is an empty string? In that case, I'll always find the word, correct? So this is one base case. So in this case, what I'll do is I'll return true. If this is not the case, that means what? My word is non-empty. Okay. So I'm gonna calculate r, which is equals to board.size, right? So this will give me rows. And if r is equals to 0, that means what? My board is empty, my friends. My board is empty, but the word is not empty. That means I can never find my board. Is that right? I'll be never able to find the word. If this is not the case, let's also calculate board 0.size, correct? So this is going to give me what? Column. This is going to give me columns. So I have the number of rows, I have the number of columns, right? Okay. Let's also create what? Visited array. I'm going to create a visited array, and I'm going to create a visited array of size r comma c. C, and mark everything as false for the timing, right? Now that this part is done, we all what am I going to do? I'm going to find the first character. For int I equals 0, I is less than r, I plus plus. Oopsie. For int j is equals to 0, j is less than c, j plus plus. If board I j is equals to word 0, right? If it is the first character which I wanted to find, that means this is the spot, correct? If this is the spot, then I have to check whether I'm going to write a helper function here, right? The helper function does all the work. Does this particular character exist or not? Okay, so I'll come back to this one. Let's first write the helper function. So bool exist. When you are searching for something, vector character address of visited, address of visited, and same case for vector bool address of what? Address of, oh shoot, what did I do? My bad. It's visited, and the first one is, and you have int x, you have int y, the location where you are standing right now. Okay. And what else do I require? I require r and c as well, right? So I'll make it const int address r, right? I'll make it const int address c. Now let's check where I am. And I also need an index where I am. Okay. Index. Okay. Let's look for it. So first, let me tell you what this function, what this code is doing. Okay. So let me tell you guys what this code is doing. It takes into the position from where you are starting, right? The position where you're starting is 0, 0, correct? Index of the character, right? The word was this ABCB. We should know which character we are checking. So we must have some sort of index to figure out, hey, I'm checking whether this is the character, whether this is the character. So I need an index as well, right? So you need an x and a y for the cell, and you also need an index to tell you which character are you checking right now, right? So every time you move the next cell, you'll also increase the value of index to index plus 1. That's right. And so apart from that, I have also written RNC here so that I do not have to compute it again. So the first time you go here, you check whether you have looked for all words or not, right? First of all, when you go here, you check whether you have So you check whether you have looked for all the words or not. And if you have not, what will you do? Let's start from the scratch so that you guys understand a little more. So let's say I'm looking for a word A, B, C, D. First thing which I did was I ran 2 for loops to figure out where is the first character, right? So this for loop will figure out where are the 2 characters, because these are the characters from where this word will possibly start, correct? These are the 2 possible combinations from where the word could possibly start. So let's say I started with this one, okay? So I am at x comma y, which is 0 comma y 0. I'm at this particular location, right? And I also have to keep track of an index, which is the character which I've already checked, right? So this is index. I've checked for this particular character that at this particular cell A is there. So let's look for idx is equals to 1. Now I have to look for B, right? So now I have to look for B around this. And I have also given R and C as the row and column so that I do not have to compute it again. So row right now is equals to 3 and column is equals to 4. So this is how the first function call looks like. This is how the first exit function is going to look like. So what you do is you come here and you try to say that, hey, I have to find idx1, right? So my target is to find idx1. Where can you move? You can move from x comma y to x comma y plus 1, x comma y minus 1, x minus 1 comma y, and x plus 1 comma y, right? And you will find out whether any of these positions is giving you idx1, whether any of these positions is giving you this character B or not. Oh, did we not pass the string? We must also pass the string as well. So let's pass the string here. Okay, does this make sense? Now I can calculate the size of the word anytime. Awesome. So now that I am here, I'll try to figure out which particular position. So first of all, x is equals to 0 comma 0, right? So this is where we started. So I'll try to check for 0 comma 1, 0 comma minus 1, minus 1 comma 0, and 1 comma 0, whether these particular positions are safe. First of all, I have to check whether these positions are safe, definitely within the grid. And second, not visited. And third, the character which I'm looking for, basically word idx, is there or not, right? These are the conditions which I'm looking for any particular cell to jump. This is not safe, the first condition is not true. This is not safe, the first condition is not true. Why is this not safe? Because even if this is within the grid, and even if it is not visited, the word index is not B. So I'm not going to go here. Is this safe? Yes, this is within the grid. This is not visited. And the word which I'm looking for is in the cell, correct? It is B. So I'll jump from xy to xy. That's fun. So the next function call, my friends, what is it going to look like? Next function call is going to be x is equals to 0, y is equals to 1, index is equals to index plus 1, which is 2, and R and C are exactly the same. Did you guys understand? Now I am here. Of course, I must have marked this thing as true as well, right? I must have marked this thing as true as well, right? So this is our big function. Let's start writing it. First, let's check if all the words have been taken care of. If index becomes greater than equals to word dot size, that means what? That means I have taken care of all the words, right? That means all the characters have been found. That means it's going to return true. If this is not the case, that means some characters still need finding. So first, let's mark this cell as true. because we are visiting it. And somewhere the backtracking step is to mark that cell as false as well. Is that right? Correct. And if we are marking it as false, that means we did not get the answer in between. So now I'm going to write the backtrack. This is the backtracking step, right? Which we always talk about. Now in between, I'm going to write the recursion functions, right? That's what we talked about. First, do something which you mark as visited and then mark as unvisited, and somewhere in between you will fit in those recursive functions. So let's do that. There are 4 possible positions for int I is equals to 0, I is less than 4, I plus plus. I can move in 4 possible directions, correct? I'll check whether the next position which I'm going to is safe or not. If is safe, the next position. If that position is safe, what do you do? If that position is safe, what do you do? You check whether you can find the word from there, right? Board, visited, word, then you have index plus 1, then X and Y I'll write. I'll just leave the space for them. And you have R and C, right? If this is giving you true, then you return true. Otherwise, you stay. Now let's write the is safe function. I told you guys what the is safe function is, right? Goal is safe. So we have to check for 3 safeties. What are those safeties? First, we have to check that the X comma Y cell is within the grid. Second, it should be not visited. And third, the character which I'm looking for at index, basically word index, is found there. Only then it is safe, otherwise it is not, right? So let's just copy this whole thing here. So this particular function as well. So I'll do if X is greater than equals to 0 and X is less than R and Y is greater than equals 0 and Y is less than C and not visited X comma Y, correct? Not visited X comma Y and board X comma Y is equals to what? Is equals to word index. In that condition alone is my function, is my next jump safe, correct? So now fill those values. Board, then you have visited, then you have word, then you have index plus 1, right? It's going to be index. Yes, it's going to be index. Then it's going to be R, then it's my bad. Next X, next Y, R and C, right? So this is the function which we are talking about. Exactly. I just have to figure out what's the value of next X and next Y. Okay. So again, I'm going to create 2 arrays the way I did yesterday, which is 0, 0, 1, minus 1, and int Y moves is equals to 1, minus 1, 0, 0. Cool. So now that this function is here, I'll compute int next X is equals to X plus X moves I int next Y is equals to Y plus next move, my bad, Y move I, correct? I'm just going to fix in this next X and next Y and my work is done. अच्छा, यहाँ पे बस मैं इस फंक्शन को कॉल कर लूंगा. कैसे करेंगे? अगर पहला वर्ड मैच हो गया तो अपन लोग बोर्ड पास करेंगे, अपन लोग विजिटेड पास करेंगे, हम लोग वर्ड पास करेंगे, इंडेक्स की वैल्यू 1 पास करेंगे क्योंकि 0 मैच हो चुका है, एक्स और वाई की वैल्यू आई और जे पास करेंगे और आर एस सी की वैल्यू सेम रहेगी. If this thing is happening, you return true. If nothing matched, you return false. So this is what backtracking is all about. Okay, this is what backtracking is all about. These codes should click with you. Let's jump to the next problem. So what I did was I uploaded this code to my repository. I'll make that repository public. Where is it? Okay. So I've added code for I think I did not add word search. I'll do that. I'll try. But yeah, I have just uploaded few of the code for recursion and for searching sorting. Don't copy these codes and submit it in your lead code. I mean that will be bad. That's why I was not giving you guys the code. Okay. Chalo, let's start with the next question. The next question is power x of n. I'll not write the code for this one. I'll probably do, but just hear me out. This is a rather easy question, easy medium. I'll still say it's an easy question. What does it says is you're given an x and you're given an n. You have to find out the value of x raised to the power n. You have to return the power of value of x raised to the power n. And given that this problem, the size of this value can be huge, you do a modulus p as well, where p is a prime number. It's 10 is per 9 plus 7. Okay, it's this value. This is one really large prime number. Okay, so you're given x, you're given n. You have to find x raised to the power n, but make sure you do a modulus p as well. Let's say I want to find out the value of 5 raised to the power 23. I don't know. Okay, so since 23 is an odd number, हम लोग एक काम करते हैं कि अगर मुझे 5 raised power 23 find करना है, so wouldn't it be equal to 5 raised power 11 into 5 raised power 11 into 5, right? Because 11 plus 11 is 22 plus 1, right? I'm just trying to break it down. अगर मुझे 23 की पावर निकालनी है, तो अगर मैं 11 की पावर निकाल चुका हूं, तो 11 की पावर को 11 की पावर से मल्टीप्लाई करो तो 22 की पावर आ जाएगी. 22 पावर के साथ 5 मल्टीप्लाई करो तो 23 की पावर आ जाएगी. So let's do one thing. Let's break it down. If it is an odd number, somehow my system is lagging today. I don't know why. No worries. So 23 is an odd number. So let's do one thing. 23, let's divide it into two parts, 11 and 1, because it's an odd number. Okay. So if it is an n, so just do, sorry, my bad, n by 2. So in that case, n by 2 is equals to 11. Now, next thing, if it is n by 2 and it is 11, let's do the same thing with this. It's an odd number, 1. 11 by 2 is 5. Again, it's an odd number. Divide by 2 is 2 and 1. 5 of 2, again, it's an even number. So I'll just do power of 1 and that will give me the solution. This is 0. Okay. So I can calculate 5 raised power 1. If I calculate 5 raised power 1, I can do it 5 raised power 1 into 5 raised power 1 and it gives me 5 raised power 2. If I have 5 raised power 2, I can calculate 5 raised power 5 by 5 raised power 2 into 5 raised power 2 into 5. If I have 5 raised power 5, I can do 5 raised power 11. How? 5 raised power 5 into 5 raised power 5 into 5. And same is the case with 23. I have 5 raised power 11 ka value with me. 5 raised power 11 into 5 raised power 11 into 5. And that's my answer. It's quite straightforward, right? Very straightforward, I'd say. But here is an interesting part. What if there is a modulus p involved? Huh? What if there is a modulus p involved? In that case, what will you do? So we'll discuss two cases. This is one case where modulus p is involved. Let's say I want to figure out how to do that. So I'll just revise these concepts for you. For those who don't know the modular arithmetic, so there is this one on Khan's Academy. I always go there. So this is one formula. Then we have modular multiplication as well. So it says if a plus b mod c, if we have to calculate a plus b mod c, it is equals to a mod c plus b mod c into mod c. of the solution answer of this ka mod c one more time. Similarly, if you have a minus b mod c, do the same thing as well. A mod c minus b mod c ka whole ka mod c. Okay. Similarly, if you want to do where is it? Modular multiplication. Yeah, so if you have a into b mod c, it is a mod c into b mod c ka whole mod c. Okay. And I think there is one more for exponential, faster modular expo. Yes, not this one. I hope it's this one. Oh, no, not. Modular multiplication. I think this may have it. No, modular exponentiation. Yes, million. It says a raised to power b mod c is equals to a mod c raised to power b ka fir se mod c. What does that mean? Let me explain it. So we learned 4 formula. It says a plus minus b mod c is equals to a mod c plus minus b mod c. The result of this ka mod c. Then you have a into, in fact यहाँ पे into भी लगा लो, a mod c into b mod c ka whole mod c. But the interesting part is a raised to the power b mod c. This is equals to a mod c raised to the power b ka mod c. Got it? So why is this? Why are we talking about this? It helps you solve out big problems. Sometimes it helps you figure out, go around overflow. Otherwise, your code will definitely go in overflow because there's a limit to an integer. So it says, for example, look at this particular number, a raised by b mod c, right? So if I want to calculate 13 raised power 9 mod 10, let's say, I mean, this is mod 10 or mod 8, let's say. Okay. So what you can do is, the answer to that is, you can either calculate 13 raised power 9, which can go out of overflow. Basically, it can go overflow. All you can do is 13 raised power 13 modulus 8 raised power 9. It is 5 raised power 9 modulus 9 again, right? So you can solve it this way. And you can also reduce this complexity by using a into b mod c. So it's a mod c into b mod c ka whole mod c. So it becomes much more easier that way. Okay. So this is one thing which I wanted to discuss. It was modular arithmetic. Practice a couple of questions around that, right? It will help you understand few things. Next thing which I want to discuss is what if the value of x is negative? You guys never ask me what the value of x can be. Okay, chaliye. So what if x is equal? What is if x is a negative value? What if I want minus 3 raised power 2? In that case, what will you guys do? What will be the answer to this one? So it can be basically viewed as 3 raised power 2 and minus 1 raised power 2, correct? So I'm going to find this using the usual way, but this particular one, right? So it depends on what the power of 1 is. If the power of 1 is odd, so yes, if the power is odd, it's going to give you minus 1. If the power is even, it's going to give you plus 1, right? So it's minus 1 raised power 2, which is 1, into 3 raised power 3 raised power 2, which is 9. So the answer of minus 3 raised power 2 is going to be 9. Okay. I'm going to explain one more problem जो हम लोगों ने कल थोड़ा सा डिस्कस किया था. The third problem हम लोग जो करने वाले थे, it is so अपन लोग ने ये दोनों प्रॉब्लम कर लिए. I'm going to jump to power set. It's an easy problem और हो सकता है मैं इसका कोड ना भी कराऊं क्योंकि कोड छोटा सा है, बट ठीक है, अगर टाइम लगेगा तो अपन देखेंगे, वरना मैं करा दूंगा. ओके, सो हियर इज द क्वेश्चन. कल हम लोगों ने इस क्वेश्चन को डिस्कस किया था. लेट्स से यू हैव अ सेट, you want to generate all the power set of this, right? So the power set contains an empty, then only 3, then only 4, then only 5, then 3 4, then 3 5, then 4 5, and then 3 4 5. So this is the power set for 3 4 5, right? This is the power set for 3 4 5. Now we want to generate this power set using code. How can I do that? So let's do one thing. Okay, इसमें simple backtracking अपन लोग use करेंगे, ठीक है? So the problem is that if you have n number in the set, how many power set will be generated? Power set is 2 raised power n. I'm gonna write this code really fast. Vector int, correct? And let's call generate set, and inside this you have vector. The one condition for that is what? The one condition for that is the element of the set are unique. If they are not unique, what will happen? You'll have redundant elements in power set which you don't want. Okay, so now if vec dot size is equals to empty, what do you call it? Is equals to 0. In that case, what you do is, yeah, my system is lagging for some reason. You return an empty set. Otherwise, you create a vector of vector int result, and you also create a vector and you call it what? Set so far, let's say. This is also empty. This is a null set from where we are starting. Okay, now you call the generate set. This is the helper function. Okay, now what this will take is, it will take the result, it will take the set so far, it will also take the vector, and we need to take the index as well, like how many elements has been taken care of. Then what you do is you return the result.